All right, folks, let's continue where we left off. We left off at 5.2.4, sorry, at 5.2.3. Now they say in 5.2.4 that we must draw a sketch of this graph of the inverse of the graph. So now remember, we said the equation of our original graph was 2 to the x, okay? And they drew it for us, and it looked something like this. This was Q, this is 0, 1, and they gave us a point, -1.5. Okay, so they want us to draw the inverse now of this. We found in 5.2.3 that our inverse, the equation of our inverse, was log base 2 of x. So this is what they want us to sketch. Okay, and they say we must give the coordinates of 2 points that lie on the inverse. So where are we going to get the 2 points from? We're going to use these 2 points. Okay, we know that our inverse will go through 1, 0, because remember, in the inverse, x becomes y, y becomes x. So it's going to go through 1, 0. We know it will go through there. And it will also go through a half, -1. So a half, -1 will be somewhere here. Okay, so this is 1, 0, and this will be a half, -1. Okay, so our sketch will look something like this. Let's draw it in blue, something like that. Okay, if you're not sure, you can always use the axis of symmetry, which is the line y is equal to x, which goes through something like that. So this here is the equation, which is log base 2 of x. That's our answer to 5.2.4. Okay, what does 5.2.5 want? 5.2.5 says, read off from your graph the values for which log base 2 of x is bigger than -1. We want to know, where is this greater than -1? Okay, so this question wants you to think horizontally and vertically at the same time, because they're saying for what values of x, right? So that's the horizontal. Is the graph bigger than -1? In other words, the y of this function is bigger than -1. So if you draw the line y is equal to -1, it's a line that goes like that, okay, through -1. So they want to know, where is the graph above that green line? So where does the graph start being above that green line? For what values of x? So it starts being above the green line from here, going that way. Okay, but what is this? What's the x value here? It's a half. Okay, so from a half, the graph is above the green line. So that simply means that the graph is above the green line for all x values bigger than a half. But x is an element of real numbers. So it's for all real numbers bigger than a half. Okay, and it's not bigger than or equal to, because -1 is not included there either. Okay, all right, let's look at 5.2.6. Let's squeeze it in here. 5.2.6. They say if g of x is equal to 100 times 3 to the x, right? Determine the values of x for which h of x is equal to g of x. Okay, very simple. We know what our h of x is. Our h of x is 2 to the x, remember? So they want to know what values of x is 2 to the x equal to 100 times 3 to the x. Where am I getting this from? From the question. Right, so we need to solve for x now. It's an exponential equation, right? We need to get the bases to be the same. Okay, and that's the first problem. And the second problem here is that our x's are split. They are on either side of the equal to sign. So first step, let's get them together to be on one side. So let's divide both sides by 3 to the x. So it's 2 to the x over 3 to the x is equal to 100. Okay. This, according to log number 4 of exponents, is simply that is equal to 100. Remember, we need to get the bases to be equal, but there's no way that you can write 100 with the base of 2 to the 3 of 2 over 3. So we need to use logs. Okay, so let's take the log of both sides. Okay, right? Log laws says I can bring this down. So this means x times log of 2 over 3 is equal to log 100. Okay, so allow me to continue this on this side. Okay, I want x on its own, so let's divide both sides by log 2 over 3. So x is equal to log 100 over log 2 over 3. Okay, which if you want, you can write it as log base 2 over 3 of 100. And you can enter that on your calculator, either from here as it is here on your calculator, or you can enter it like this. It matters not, it will give you the same answer. So log base 2 over 3 of 100. Okay, so it means that my x is equal to, if I round that off to 2 decimal places, negative 11.36. Right, that is my value of x. Okay, that's 5.2 done. Let's move on to question 5.3 now. Okay, I'm going to erase all of this because 5.3 has nothing to do with any of this. All right, what does 5.3 say? 5.3 says the price P in rands per unit of each item in a consignment of Q items is given by P is equal to log 10 plus Q over 2. Okay, so if you want to work out the price per unit in rands of whatever this is that's being transported, I presume, you go log and enter that 10 plus Q over 2, where Q is the number of items. All right, so 5.3.1, calculate the value of P and the total price of the consignment when the consignment is 1,980 items. So it means that if my Q is equal to 1,980, what is the price? Okay, so it means that instead of Q, I'll put this number. So it's 1,980 over 2. You enter that on your machine calculator. There's no need to simplify this. So it's going to be log 10 plus 1,980 over 2, close bracket, gives us 3, right? So what are they asking us to work out? The value of P and the total price of the consignment. Okay, so what is the total price? Remember, there are 1,980. So therefore, total price, because this is the price of one unit, will be 3 times 1,980. Okay. So that means that the total price is 5,940 Rand. 3 easy marks, right? That's 5.3.1. Let's look at 5.3.2, the last question of question 5. Okay, let's go with the blue marker. Black is running dry. Right. Determine the number of items, Q, number of items in the consignment when the price of each item is 2 Rand. So when P is equal to 2, what is Q? And this question is an easy 2 marks. So remember, P is equal to log, okay? My P is 2, so 2 is equal to log of 10 plus Q over 2, and we need to solve for Q. All right, so what's the first thing we do? Remember your log laws. We need to write this in exponential form, okay? There's an invisible 10 here. So if I say log of anything, log 5, log 10, the base is always 10, all right? So in exponential form, this means that 10 to the power of 2 is equal to 10 plus Q over 2. If you've forgotten your log laws, please go and revise your log laws. Now this is very easy. We can now just solve for Q. So let's take this over. So this 10 squared is 100. Okay, but let's do it like this first, step by step. So this is 100 minus 10, which is 90, is equal to Q over 2. Solving for Q means multiply both sides by 2, right? So my Q is equal to 90 times 2. So my Q is equal to 180 items. So that is the number of items in the consignment when the price of each unit is 2 Rand. Okay, so that's the end of question 5. Come back again later for question 6, which is the last question of the functions in last year's prelim paper. See you later.